again. Today is Monday, January 3rd, 2022. And I'm sitting at my desk at home. Today I'm gonna read interesting scientific article as a part of my daily English reading exercise. I'm just reading materials to hone in on my English, to practice my English. Here we go. Big Think. The future, December 4th, 2021, SpinLaunch. Company hurls satellites into space using giant spinning machine. SpinLaunch's launcher, which is larger than the Statue of Liberty and works like the Olympic hammer throw event, just came online in the New Mexico desert. Looks very big. The size of the Statue of Liberty, larger. I wonder what's the a pit next to the hurl. It's a concave. Maybe it holds some water. Key takeaways: rocket fuel is very expensive, and burning it releases a lot of greenhouse gases. Like the Olympic hammer throw event, SpinLaunch hurls satellites into space. The company says its approach will be 10 times cheaper and require 4 times less fuel. That's good. It consumes less fuel and 10 times cheaper. 10 times cheaper. This article was originally published by our sister site, Free Think, and this site is Big Think. The future of satellite launches may be taking shape in New Mexico, where a startup just tested out a system designed to fling the objects into space rather than blasting them into orbit with the rockets. Fling, okay? Blasting. Fling, blasting. Fling the objects into space. Tested out the challenge to put satellites into space. We load them onto a rocket carrying a ton of propellant, then burn that propellant to create thrust. This allows the taking shape. Yeah, I'm gonna write it down. Taking shape, thrust. This allows the rocket to break free of Earth's gravity, and once it's high enough, it can release its payload. Break free of Earth's gravity. Yeah, I studied mechanical engineering, so all those terms were quite familiar to me, and I feel cordial. The development of reusable rockets has made its process a lot cheaper. We used to just have to eat the cost of an entire rocket as a part of a launch, but fuel is still very expensive, and burning it releases a lot of greenhouse gases. Satellite launches 2.0. California-based spaceflight startup SpinLaunch SpinLaunch is testing a different approach to satellite launches, one that involves spinning them really fast and then letting them go at just the right moment. The more crazy the project is, the better off you are just working on it rather than talking about it. Jonathan Yaney. It's sort of like the Olympic hammer throw event, but with the satellites instead of metal balls And even SpinLaunch's own CEO, Jonathan Yaney, knows that that sounds bizarre, which is why the startup has largely operated under the radar for the past 7 years. 7 years. Under the radar. Okay. I find that the more audacious and crazy the project is, the better off you are just working on it rather than being out there talking about it, he told CNBC. We had to prove to ourselves that we could actually pull this off. Okay, make it happen. Pull this off. Audacious. The Biden administration is not audacious. The Trump administration was. The project's not seeming so crazy now, though. First flight on October 22nd, SpinLaunch used a vacuum-sealed suborbital accelerator taller than the Statue of Liberty to spin a 10-foot-long projectile on a rotating arm until it reached a speed in the many thousands of miles an hour, according to Annie. When released out of the accelerator's barrel, the projectile flew to an altitude in the tens of thousands of feet, he said. SpinLaunch says its approach will be 10 times cheaper and require 4 times less fuel. Within the next 8 months, SpinLaunch plans to conduct about 30 more tests of its suborbital accelerator in New Mexico, which was only putting 20% of its total power behind this first test flight before building a larger orbital accelerator capable of putting satellites into orbit. We can essentially validate our aerodynamic models for what our orbital launch vehicles are going to be like, and it allows us to try out new technologies when it comes to release mechanisms. Annie said, scaling up release mechanisms, try out, test out, try out, test out, scaling up. SpinLaunch expects its orbital system will be able to deliver about 440 pounds, 200 kilograms of payload into orbit per launch, the weight of 2 small satellites. During those satellite launches, the projectile will coast for about a minute before splitting open. A booster affixed to the payload will then give it an extra push to guide it into its orbit. Each payload booster, each payload will be a tiny fraction of what most rocket launches carry. SpaceX's Falcon 9, for instance, can carry over 50,000 pounds or 22,800 kilograms to low Earth orbit, LEO, low Earth orbit. However, SpinLaunch says its approach will be 10 times cheaper and require 4 times less fuel than what's currently used to put payloads of its size into orbit. It also produces zero emissions in the most critical layers of the atmosphere. Zero emissions, okay? Zero emissions. And because the system is so cheap, they can perform a lot of launches, making up with volume what it lacks in payload size. The company making up with the volume what it lacks in payload size. The company is looking for a site for its orbital accelerator that can support dozens of launches per day, and it expects to conduct its first customer launches in late 2024. That's 2 years from now. Looking ahead, if SpinLaunch can cut the cost of putting small satellites in space, the ripple effect could be huge. The ripple effect could be huge. Microgravity gives scientists the ability to perform experiments that are impossible on Earth, and cheap access to it could lead to breakthroughs in tech, manufacturing, healthcare, and more. SpinLaunch isn't the only company exploring unique ways to cut the cost of getting to space either. UK startup B2 Space is developing a balloon to carry rockets into the upper atmosphere. Like a SpinLaunch's system, this would cut both the cost of fuel and the amount of emissions released in the lower layers of the atmosphere, suggesting the future of satellite launches might be cheaper and cleaner. So the expressions I learned from this article was actually those expressions and words I know long time ago, but while reading this article, I just decided to remind the following expressions. I'm just writing from my heart, from my mind. Let's see, try out, test out, fling the objects into space, blasting, cleaner, low Earth orbit, LEO, a lot of greenhouse gases, atmosphere, a stratosphere, a startup company, B2 Space, launch, hurl, hammer throw event, hammer throw sport, of blasting, fling, testing out, startup, scaling up, making up with volume where it lacks in size. Okay, size does matter. Okay, space launch, orbital. Elon Musk, space launch. Cleaner, atmosphere. Let me go over what I wrote on my paper. Fling, taking shape. It is taking shape. Thrust. Break free of Earth gravity. Break free of Earth gravity. Startup. Under the radar. Pull this off. Make it happen. Under the radar. A low profile. Under the radar. Audacious. Try out. Test out. Scaling up. Boosted. Booster shot. Booster. Zero emissions. The ripple effect is huge. The ripple effect is huge. The ripple effect is huge. Okay, that's it for today. Thanks for listening. Bye bye.